Hello students, welcome to Energy Conversion 2 class. We are studying chapter 4, that is single phase induction motor. Now we will start with capacitor start induction run motor. This is the circuit you can see students. Here is the single phase supply. This is the rotor. This is the main winding of the motor and this is the starting winding of the motor. And this is connected a capacitor of C value and a switch is used here as shown with name S. Here is the current flowing through the main winding IM. This is the current flowing through the starting winding, that is IS. In these motors, the necessary phase difference between IS and IM is produced by connecting a capacitor in series with the starting winding as shown in figure. So we can see here this is the capacitor connected and you can see these are two windings. This is the starting winding, this is the running winding. So the capacitor is generally of a electrolytic type and is usually mounted on the outside of the motor as a separate unit. Here we can see in the figure, this capacitor is connected through a switch that is connected in series with the starting winding and it is always connected outside of the motor as a separate unit. The capacitor is designed for extremely short duty service and is guaranteed for not more than 20 periods of operation per hour, each period not to exceed 3 seconds. When the motor reaches about 75% of full speed, the centrifugal switch S opens and cuts out both the starting winding and the capacitor from the supply, thus leaving only the running winding across the lines. Now the capacitor start induction on motor phasor diagram. Here we have taken voltage as reference. This is the main winding current. This is the starting winding current. This current lags the voltage with an angle of phi. This current, starting winding current, leads the voltage. Okay, we can see here this is the angle. Now the resultant current will be I, is shown here, and the resultant current I will lag the supply voltage with an angle. As shown in figure, current IM drawn by the main winding lags the supply voltage V by a large angle, whereas the starting winding current IS leads V by a certain angle. The two currents are out of phase with each other by about 80 degrees for a 200 watt 50 Hz motor as compared to nearly 30 degrees for a split phase motor. Their resultant current I is small and is almost in phase with supply voltage V. Now this is the torque speed characteristic. Here you can see this is the torque during starting condition. This is the torque during running condition. Since the torque developed by a split phase motor is proportional to the sine of the angle between IS and IM, it is obvious that the increase in the angle from 30 to 80 alone increases the starting torque to nearly twice the value of the developed torque at the starting time. Other improvements in the motor design have made it possible to increase the starting torque to a value of 350 to 450%. Typical performance curve of such a motor is shown in figure. Now this is capacitor run motor. So this is the supply voltage. This is the main winding. Here is the auxiliary winding. This is the capacitor connected in series, and here is the squirrel cage rotor. Connection scheme of the capacitor run motor is same as the capacitor start motor, except the absence of centrifugal switch S. The capacitor is of paper type. The capacitor is permanently connected to the starting winding. In case of the paper capacitor, the value of the capacitance is small since it is difficult and become uneconomical to manufacture paper capacitor of higher value. The electrolytic capacitor cannot be used since this type of capacitor is used for only short time rating and hence cannot be permanently connected to the winding, but both main as well as starting winding is of equal rating. Here is the characteristic of capacitor run motor. This is the percentage of speed. This is the full load torque. Here we can see this graph is starting from here. The torque is full load torque is 50% of the starting torque and it settles down at synchronous speed. Starting torque is lower, about 50% of the full load torque. Power factor is here improved. It may be about unity. Efficiency is improved to about 75%. The direction of rotation can be reversed as retained in case of capacitor start motor. The capacitor run motor is used in fans, room coolers, portable tools, and other domestic and commercial electrical appliances. Now, capacitor start capacitor run motor. Here you can see two capacitors are used, CS, CR. Okay, capacitor at starting, capacitor at running, and here is a centrifugal switch. Yes, this is the squirrel cage rotor. Here is the starting winding. Here is the main winding. This is the supply voltage. This is the main winding current. This is the starting winding current, and I is the total armature current or the total current in the circuit. Two capacitors are used in capacitor start capacitor run motor or two value capacitor motor it is also called. One for starting purpose and other for running purpose. Starting purpose capacitor is of electrolytic type and is disconnected from the supply when the motor attains 75% of the synchronous speed with the help of centrifugal switch S connected in series with the starting capacitor. The value of the two capacitor is different. Starting capacitor CS, which is electrolytic type, is of high value. Now, this is the characteristic of capacitor start capacitor run motor. This is the percentage torque. This is the percentage synchronous speed. So we can see this is the main and auxiliary winding. This is only the main winding. The capacitor start capacitor run motor gives the best running as well as starting conditions. Such motors operate as two-phase motors, giving the best performance. Starting torque is high, starting current is reduced and gives better efficiency and better power factor. The only disadvantage is its high cost. Direction can be reversed by interchanging the connection of supply to either of the main winding or the starter winding or the starting winding we can say. Next is shaded pole type induction motor. What is a shaded pole motor? A shaded pole induction motor is a single phase induction motor which is self-starting with one of the poles shaded by copper ring. The other name of the copper ring is a shaded ring, where it acts as a secondary winding motor. It rotates only in one direction, particularly, and reverses its movement if possible. This motor has very high power induction losses and also has a very low power factor. Starting torque induced in the motor is very low. Due to these reasons, it has poor efficiency. It has low power ratings. It is also a salient pole split phase motor. Here you can see the diagram. This is the main winding. These are the main poles. This is the shedding coil made up of copper. This portion is threaded. For this pole, this portion is threaded. This is the cage rotor. This is the stator. And here is the single phase supply. So, it has two poles as shown in basic construction. This motor is made up of stator and a rotor which is cage type. The stator has projected poles also called main poles in it. The supply winding on the main poles forms the main winding. The poles in this motor are unequally divided into two halves, whereas the smaller portion is threaded portion that carries a copper band. Copper ring, which is a single turn, is fitted on the smaller part. This ring, also known as shedding coil. The shedding coil fitted on the main pole is called the shedding pole. When power is supplied to the stator, flux is induced in the main part of the pole. This flux induces a voltage in the shedding coil. This acts as the secondary winding. By Lenz's law, the current direction should be in such a way that is opposing the flux entering into the coil. This acts as a secondary winding of the transformer. In the core, when a single phase is applied, an alternating flux is generated. This flux links with the shedded coil in fraction amounts. Then voltage gets induced in the coil due to the variation in the flux linking. Hence, the shaded portion is short-circuited, due to which it produces the circulating current in it. In such a way, the direction is opposing the main flux. Shaded pole motor working, the main core flux is opposed by the flux in ring that is developed by the circulating current. Hence, flux is induced in the shaded portion of the motor along with the unshaded portion with a phase difference, which is lagging behind the unshaded pole flux. There is also a space displacement that is less than 90 degree between a shaded ring flux and the main flux. So, working. The operation of the motor can be understood by referring to the figure which shows one pole of the motor with a shedding coil. Considering a cycle of alternating current applied to the stator winding, we will explain the working of shaded pole motor now. This is the AC cycle applied to the motor. We will study now bit by bit from O to A, A to B, B to C, and hence.